Okay, so we've been talking about earthquakes that do not occur at definable plate boundaries. And we've seen that many of them occur at rifts, where continents are pulling and breaking apart. Many of them occur at collision zones, where two continents are squashing together. There's a third type called intraplate earthquakes, intra meaning within. Intraplate earthquakes are those that are not really associated with rifts, collision zones, or plate boundaries, but are occurring within an area that is the interior of a plate, away from the plate boundary. Now, to get a sense of intraplate earthquakes, let's look at this map showing the location of epicenters in the eastern two-thirds of the United States. Now remember that North America is part of the North American plate, but that the North American plate includes not only the continent of North America, but also the western half of the Atlantic Ocean floor. So the plate boundary is actually way to the east, where the mid-Atlantic ridge is, that submarine mountain range that runs down the middle of the Atlantic Ocean. The western boundary of the North American plate is the San Andreas Fault, or the Cascade subduction system along the west coast of North America. Note that some plate boundaries are out in the middle of the ocean floor, some plate boundaries are along the edge of the ocean basins, and some plate boundaries are along the edge or the coastline of a continent. But note that not all continental coasts are plate boundaries. So geologists make a distinction between those continental coasts that are plate boundaries, and those are called active margins, and those continental coasts that are not plate boundaries, and those are called passive margins. So say, for example, in the case of South America, the west coast of South America is an active continental margin. It coincides with a plate boundary and is the site of many earthquakes. In contrast, the eastern margin of North America is a passive continental margin, as is the east coast of South America. These are continental margins where there is a boundary between oceanic crust and continental crust, but there is no seismicity and there is no relative motion. We're looking at a map of the eastern two-thirds of the United States. Remember that this region is in the interior of the North American plate. The eastern plate boundary, the mid-Atlantic ridge, is way off the map in the middle of the Atlantic Ocean. The western plate boundary, the San Andreas Fault and the Cascade volcanic chain, is off to the west along the west coast of North America. So this is an intraplate setting, and yet there are many red dots here representing epicenters of earthquakes. And in fact, there are clusters of red dots representing seismic zones. They're not long, continuous seismic zones like plate boundaries, but nevertheless, they are clearly seismic zones. Perhaps the most prominent of these is the New Madrid seismic zone, which occurs along the Mississippi River Valley, just along the southeasternmost corner of the state of Missouri. Now, I pronounce it New Madrid because that's how it's pronounced locally, even though it's spelled the same as the city Madrid. Now, New Madrid had a number of major earthquakes, actually 3 major earthquakes, back around 1811, 1812. Since then, there have been many, many earthquakes. Most of them are smaller than magnitude 4 or 5, so they're not great earthquakes. But one of the stories about earthquake hazard is that where earthquakes have happened in the past, it's possible that they can happen in the future. So it's possible that there could be large earthquakes on the New Madrid system sometime in the future. Other belts that we can see here, there's earthquake activity in eastern Tennessee, there's earthquake activity near Charleston, there's earthquake activity near Montreal. All of these earthquakes are intraplate earthquakes, and why they occur is not fully understood. One of the explanations is that they occur along ancient but still weak fault zones, and that the continent of North America, even though it's not a plate boundary, the rocks of the continent are still under stress. They're being compressed due to the activity along the edge of the plate boundary, due to the interaction of the plate with the underlying mantle. And sometimes these stresses are significant enough or become large enough to cause the rock along a long-lived fault to suddenly fail, the fault suddenly slips, and that generates an earthquake. Looking at an overall map of the planet, we can test our knowledge and now understand why the seismic belts occur where they do. For example, the west coast of South America, that's a seismic belt because of the subduction of Pacific Ocean floor beneath South America. It's not the Pacific plate, actually, it's the Nazca plate, but nevertheless, it's subduction. Why is there seismic activity down the middle of the Atlantic Ocean? That's the mid-Atlantic ridge, a divergent plate boundary. Seismic activity along Japan, that's subduction of the Pacific Ocean floor, Pacific plate, and the same with the Aleutians. Why is there earthquake activity down the middle of the Indian Ocean? That's, again, a mid-ocean ridge. And the earthquake activity in Africa, the East African Rift. The earthquake activity in a stripe from the Alps to the Himalayas, that's due to collisional tectonics. So now you can look at a map showing the distribution of earthquakes on our planet. And their distribution is no longer a mystery. They're easily understandable by understanding the basic principles of plate tectonics.